we're going to change gears a little bit and talk about sequences. So what exactly is a sequence? A sequence is just an ordered list of numbers. We could have the sequence of odd numbers, 1, 3, 5, 7, 9, etc. And there are lots of different sequences. And in general, we denote them like this. We use braces, and we write a sub n, and then that's equal to our actual list of numbers. There are lots of ways to actually define this properly, so let's talk about a few of these definitions. The first way we're going to define things is with an explicit formula. And an explicit formula is a formula that defines the nth term. As an example, if I say an equal to n cubed, this is a way to define our sequence. If n is 1, I have 1 cubed. I then have 2 cubed, 3 cubed, 4 cubed, etc. So no matter what value I want, I can just stick that number n for n, and I get out that term of the sequence. The next way to define sequences that we're going to deal with is a recurrence relation. And a recurrence relation defines a term by its previous term. Here's an example of a recurrence relation, a sub n equal to an minus 1 plus 4, and a1 equal to 1. With recurrence relations, you do need to have starting conditions. That's what that a1 equal to 1 means. The next term, I'm then going to stick in for an minus 1. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17, etc. You define one term by knowing what its previous term is and then doing some kind of operation. Recurrence relations are not ideal because, for instance, in an explicit formula, if I want to know the 100th term, I can just stick in 100. But for a recurrence relation, if I want to know the 100th term, I need to first figure out the first 99 terms, so it can be a lot more work. Another way we can define a sequence is in list form. In list form, we just write out some terms and then say it keeps going, usually with an ellipses. And this is not ideal because, for instance, whenever I write out a few terms and then say it keeps going in this pattern, well, I'm assuming that you can recognize the pattern in the first place, and so if you can't recognize that pattern, this can be kind of difficult. There are lots of other ways as well, but let's figure out exactly what a good definition looks like. First, we're going to say that we want to define the sequence a sub n. So after that, I'm going to outright give it a formula. I'm going to set a sub n equal to negative 1 to the n over n squared. So now that we've seen some of these definitions, let's see if we can figure out how to work with some of these sequences. So I have the sequence negative 1 to the n over n squared from 1 to infinity. And I'm going to try to define some of these terms. In particular, I'm going to try to find the first 4 terms. a1, a2, a3, and a4. For 1, I now have negative 1 to the first power over 1 squared, which is just negative 1. For 2, negative 1 squared over 2 squared, which will be 1/4. For 3, negative 1 cubed over 3 squared is going to be negative 1 over 9. And then for 4, negative 1 to the 4th over 4 squared, which is 1 over 16. Now I have sine of n pi over 2, and once again we're going to try to find the first 4 terms. If n is 1, I have sine of pi over 2, which is 1. The next one, sine of 2 pi over 2, will be sine of pi, which is 0. Sine of 3 pi over 3, or 3 pi over 2, which is negative 1. And then sine of 4 pi over 2, which is the same thing as sine as 2 pi, is 0. So now I can see I'm alternating 1, 0, negative 1, 0. If I continued, I'd go back to 1, 0, negative 1, 0 again. Now that we have a basic understanding of sequences, let's talk about a few of the different definitions that represent types of sequences. The first is an increasing sequence. And this means exactly what you would expect. It means every term is bigger than the one before it. Something like 1, 4, 9, 16, 25, etc. is an increasing sequence. Decreasing is then going to mean exactly the opposite. We want each term to be smaller than the one before it. Like 1, 1/2, 1/3, 1/4, 1/5, etc.